Kia ora koutou katoa, it's Mrs. Goodson here. This video is for Chemistry 2.4 Bonding and Structure, and it's all about justifying whether a molecule is polar or non-polar in terms of its shape and the presence of polar bonds. So I'm going to break this down into two videos. The first video is going to be about how to identify whether a molecule has polar bonds, and the second part is going to be all about whether a molecule is polar or non-polar. So first of all, we have to learn what electronegativity is. So electronegativity is a measure of an atom's attraction for a bonding pair of electrons in a covalent bond. So this cartoon kind of shows it. If the atom is highly electronegative, it's going to be able to have a strong pull on these electrons in the covalent bond, and that means that these electrons are going to spend more time closer to this atom than it is to this one. So if they are the same type of atoms in a covalent bond, then they're going to share these electrons evenly. But if one atom is much more electronegative, then it's going to have a stronger pull on these electrons within the covalent bond. For example, sodium has a low attraction for electrons, whereas fluorine is actually has the highest electronegativity of any atom. And so you can look at the periodic table and say the closer an atom is to fluorine on the periodic table, then the higher the electronegativity. So atoms that are very high, have high electronegativity are fluorine, oxygen, nitrogen. Chlorine is This is in order from high to low, okay? Chlorine and the halides, then sulfur, carbon, and hydrogen, okay? So the first three are really important for what's called hydrogen bonding, and we're going to look at that kind of attraction between molecules a bit more in level 3 chemistry. But you need to know that electronegativity increase across a period of the periodic table and decrease as you go down a group. So in a group 18 atoms, they don't form covalent bonds, so they have they've got full outer shell, so they have almost no attraction for electrons. So they aren't included in this. They're just not part of the definition, really. Okay, so what is a dipole? So if you think of the North Pole and the South Pole, it's some sort of opposites. It's on the opposite side of the world. And so when we're thinking about atoms and electrons, we're thinking about opposite charge. Okay, so the opposite to positive is negative. So if you have, in this picture here, we've got a bond between a hydrogen atom and a fluorine atom. Now the fluorine is a lot more electronegative, and so the electrons are going to spend more time down this side of the bond. So we use this little delta, which means slightly. It's not completely negative because then it would be an ionic bond. It's still a covalent bond, they're still sharing the electrons, it's slightly negative. And the hydrogen is then electron poor, so it ends up being slightly positive. And we can draw this symbol here is a picture of the dipole. So plus at this end, and then it's going, so we can draw the dipole. So the slight separation of charge, it's not as big, nowhere near as big as ionic between ions, but we call it a dipole. Okay, so this is going to be important as we think about different types of bonds. So if two atoms that are the same, like two chlorines, share electrons to make a bond in Cl2, for example, then there is no charge on the atoms. Okay, they're both the same atom, so they've got the same electronegativity. The electrons, there's no dipole. On the other end, over here, the atoms are so different to each other that the sodium actually gives up its electron completely and forms ions. Okay, so we talked about ionic bonds in earlier videos, so go back and check those if you're still not sure about ionic bonds. But this is non-polar covalent bonds is equal sharing, but polar covalent bonds is non-identical, different nonmetals, and so that they unequally share the electrons, and so you end up with this partial charge, slightly positive or slightly negative. So you end up with this continuum of bonding. So you've got non-polar covalent bonding at this end through to polar covalent bonding and ionic bonding at this end. So we're going to focus in on the polar covalent bonds where there's a slight difference in electronegativity, but they're still sharing the electrons. One end of the molecule is slightly positive, the other end is slightly negative. And so you end up with this permanent dipole, permanent separation of charge. And we say it's a polar covalent bond. And so we use these little delta signs, slightly positive, slightly negative, or draw the arrow there. So how do we recognize that it's a polar covalent bond? So we're looking for two different atoms that are bonded together. The bigger the electronegativity difference between these atoms, the more polar the bond will be. So here's some examples of polar bonds. Carbon and oxygen, carbon and fluorine, all different. As long as there's a bond between two different atoms, it's going to be a polar bond. So in the next video, we're going to look at polarity of molecules, but this video has all been about polar bonds.